Recent reports from China indicate that CATL, currently the largest battery manufacturer in the world, has unveiled a new generation of sodium-ion batteries with a staggering 1,200 kilowatt charging capability. This development marks a significant leap in battery technology and could have profound implications for the electric vehicle industry. Sodium-ion batteries, once seen as a potential but limited alternative to lithium-ion technology, are rapidly emerging as a viable competitor due to their lower cost, faster charging capabilities, and steadily improving energy density. The new battery pack from CATL appears to be an upgrade of its previous design, which combines sodium and lithium cells. However, indications suggest that the latest generation may rely entirely on sodium cells. The charging rate of 1,200 kilowatts, or 12 C, represents a level of speed previously considered unattainable. This performance can disrupt not only the battery market, but also the broader electric vehicle industry, as such advancements drastically reduce charging times, improving the convenience and viability of electric vehicles for mainstream consumers. CATL is not alone in driving this innovation. Other major players in China, such as BYD, are also advancing rapidly. This puts battery manufacturers in South Korea and the United States under increasing pressure to keep up. The pace of development in China is particularly noteworthy, as it underscores the country's dominance in the battery sector and its determination to stay ahead of global competitors. A key example of this new technology in use is Huawei's EV line. The model produced through a joint venture between Huawei and another company will feature CATL's sodium-containing battery pack. This joint brand, operational since 2021, combines manufacturing expertise and platform design with Huawei's software and components. Vehicles equipped with these sodium-ion batteries are expected to enter the market soon, bringing cutting-edge charging technology to consumers. The capabilities of these batteries are particularly striking. A slide from a recent presentation highlighted the 12C charging feature, meaning a battery could theoretically achieve a full charge in as little as 3 to 4 minutes. Such speeds represent a breakthrough comparable to the leap from dial-up internet to high-speed broadband, setting a new benchmark for energy storage systems. Two configurations of the vehicle are planned, one using a sodium-based battery, and another fully electric model utilizing CATL's advanced battery pack. This pack, also known as the third-generation design, achieves an energy density similar to Tesla's 4680 cylindrical cells at approximately 255 watt-hours per kilogram. CATL claims it can fit more cells per unit compared to Tesla's design, potentially increasing the vehicle's overall range. Early reports suggest that vehicles equipped with this battery pack could achieve ranges of up to 1,000 kilometers on a single charge, making range anxiety virtually obsolete for most drivers. There is also mention of a condensed sodium battery featuring advanced thermal electric separation technology. This condensed battery is said to have an energy density of 450 watt-hours per kilogram, substantially higher than standard lithium-ion cells. An 80 kilowatt-hour battery of this caliber could provide over 800 kilometers or roughly 1,300 kilometers of driving range. While these condensed batteries are not yet widely deployed in consumer vehicles, their introduction would represent a significant shift in electric vehicle performance. So, perhaps the most revolutionary aspect here is the 12C charging capability, a 100 kilowatt-hour battery pack that's capable of handling 1.2 megawatts of power could, in theory, be fully charged in under 10 minutes. This kind of unprecedented rate of energy transfer would of course require some pretty significant advancements in charging infrastructure, from power grid enhancements all the way to new cooling and cable technologies. CATL's latest innovation really stands as a testament to the company's relentless pursuit of progress. The first generation was already considered one of the most advanced lithium iron phosphate batteries in the world, but, the second generation pushes even further beyond that reputation. With the ability to exceed 1.3 megawatts in charging speed, it honestly challenges the capabilities of any battery currently on the market, including those from leading Western manufacturers. This rapid development definitely raises some important questions about infrastructure readiness. Charging stations that are capable of delivering such massive power levels just aren't widespread yet. Most high-speed chargers today max out at about 350 kilowatts, which is really just a fraction of what these new batteries can handle. So the industry will need to adapt quickly if we're going to make full use of these capabilities. Innovations in grid technology, energy storage, and thermal management are all going to be necessary to support the shift to ultra-fast charging. The implications extend beyond passenger vehicles. Batteries with these characteristics could, really revolutionize freight and logistics, including electric trucks, buses, and heavy machinery. Sectors where charging time and energy density are critical stand to benefit immensely from sodium-ion technology. The ability to recharge large battery packs in just minutes rather than hours could make electric freight vehicles as efficient as their diesel counterparts, all while reducing operating costs. Additionally, the advantages of sodium-ion batteries extend to grid storage solutions. Their fast charge and discharge cycles, low cost and strong tolerance for temperature extremes make them, honestly, ideal for stabilizing renewable energy sources like wind and solar. As the world transitions toward a low-carbon future, affordable large-scale energy storage will be critical, and sodium batteries are really well positioned to fill that role. The next few years will determine how quickly sodium-ion technology can be scaled for mass adoption. CATL has signaled that these advanced batteries will begin appearing in electric vehicles within the next 6 months. If this timeline holds, it will be one of the fastest commercial rollouts of a new battery technology in history. The combination of rapid charging, high range, and lower cost will make these vehicles highly competitive and could honestly reshape consumer expectations worldwide. International competition is certain to intensify. Companies in South Korea, Japan, Europe, and the United States will need to accelerate their research and development efforts to keep pace with China. The unveiling of CATL's next-generation sodium-ion battery technology represents far more than an incremental advancement. It heralds a fundamental paradigm shift that could reshape the global clean energy landscape.
As competing manufacturers respond to this technological leap, we will likely witness strategic alliances, licensing agreements, and revolutionary manufacturing processes emerging across the industry. Established battery giants and startups alike will be forced to rethink their research and development roadmaps and production strategies as they attempt to bridge the growing technological gap.
So this innovation really challenges the foundations of current energy storage paradigms by delivering ultra-fast charging capabilities and energy densities that honestly rival premium lithium cells at potentially lower costs. The implications go way beyond just faster charging electric vehicles. It's about the democratization of clean transportation thanks to reduced battery costs and the elimination of range anxiety. And it also opens up new applications for electric propulsion in sectors like heavy freight, aviation, and marine transport, which were previously considered pretty impractical due to energy storage limitations. The inherent advantages of sodium-ion chemistry like superior performance in extreme temperatures, enhanced safety, and the abundance of raw materials really position this technology as a cornerstone for the renewable energy revolution. CATL's breakthrough comes at a time when global markets are reaching inflection points in electric vehicle adoption and renewable energy deployment. So this technology could honestly rapidly become the new standard. The convergence of these technical capabilities with growing environmental imperatives and shifting consumer expectations, it creates perfect conditions for mass adoption and could potentially accelerate the global transition away from fossil fuels. This isn't just about better batteries, it's about enabling a new energy ecosystem where clean, affordable, and convenient power becomes universally accessible, fundamentally changing how we think about transportation and energy storage. The true significance of this breakthrough extends beyond technical specifications. It represents a fundamental reimagining of what is possible in our global energy future. Future historians may identify this as the turning point that accelerated the clean energy transition from theoretical possibility to practical inevitability. This innovation challenges long-held assumptions about the limitations of battery technology, rewriting the rulebook for energy storage solutions. It, redefines consumer expectations about electric vehicle convenience, transforms the economic calculus of renewable energy integration, and, honestly, opens new frontiers in sectors previously constrained by energy storage limitations. This breakthrough demonstrates how technological leaps can reshape entire industries, forcing competitors to innovate rapidly or risk obsolescence. The benchmark set today will likely catalyze new waves of research and development across material science and energy system design, potentially yielding unexpected breakthroughs in adjacent fields. As this technology matures and scales, it may become the foundation for energy solutions we have not yet imagined, from fully electrified transportation networks to decentralized microgrids in developing regions. The true legacy of this advancement may be measured not just in its direct applications, but in how it expands humanity's collective imagination about what is achievable in the clean energy transition, inspiring a new generation of innovators to pursue solutions to currently insurmountable challenges. The most valuable output of this breakthrough may not be the batteries themselves, but the paradigm shift they represent, proving that with sufficient ingenuity and determination, even the most entrenched technological barriers can be overcome to create a more sustainable energy future.